Now we come towards acceleration due to gravity. Now suppose that the force of gravity is G m over r square. One of the m is capital, other m is small, and r is the distance. So G mm, that is, we assume that Earth is a solid sphere. On the circumference, a small mass is kept, and the mass of the center, that is of the Earth, is capital M. So the gravity between capital M and small m, that is between Earth and the body moving around the circumference, that is given as G mm over r square. So this force can be replaced by mg, that is the weight of the body. So from both sides we find m will cancel off, that is we are referring to small m, and the value of g will be acquired. The value of g is taken as gm over r square, and that is called acceleration due to gravity. So the gravity generated due to acceleration of the body, that is called acceleration due to gravity. So acceleration produced in a body due to the force of gravity is termed as acceleration due to gravity. The acceleration due to gravity is equal to the force with which Earth attracts a body of any mass towards its center, and that is what the definition of weight. Now, small m is given here, that is the mass of the body. F, the force of attraction at distance r from the center of Earth, then acceleration due to gravity is given as gf over m. We put the value of m and we will calculate g me over r square. So g is gravitational constant, m is the mass of Earth, and r is the distance of the body from the center of the Earth. M is the mass of Earth. The expression G is equal to Gme over R square is free from mass, that is mass of the body. So this is the equation independent of the mass of body. This means that the value of G does not depend upon the shape, size, and mass of the body. Hence, if two bodies of different masses, shapes, and sizes are allowed to fall freely, they will have the same acceleration. If they are allowed to fall from the same height, they will reach the Earth simultaneously. Now, acceleration of the body near the surface of Earth is generally 9.8 meters per second square or 981 centimeter per second square. Now we come towards the dimensional formula of small g, that is the same as that of acceleration. So it is m naught Lt minus 2. And now we come that the value of acceleration due to gravity depends upon the following factors. So we have to discuss now on what parameters the value of g depends. Number one, it depends upon the height above the Earth's surface. That we wanted to say that body is on the circumference. Then we find that g is significant. But as it goes away from the Earth, the distance of the body from the center of Earth goes on increasing, and hence the value of g, that is small g, that goes on decreasing. Next is depth below the surface. So on the surface, the value of g is significant, but as the body, if we just make a tunnel in the Earth, we will find that body, when reaches to the center, will find that its weight will be zero. That is, acceleration due to gravity is dropping. So the moment we drop a material in that tunnel, we find that its acceleration due to gravity goes on decreasing, and hence the weight is also decreasing. And then comes the shape of Earth. Shape of Earth is also deciding whether gravity is more or less. Now we assume like this, that Earth is a uniform sphere, a solid sphere, but from poles it is slightly bulging inside, and at equators it is slightly bulging outside. So we find that the polar radius is less as compared to the equatorial radius. So value of g at equators will be less, and at the poles it will be more. Therefore, weight of the body at equators will be less, and the weight of the body at poles will be more. And then comes the actual rotation of the Earth. Actual rotation of the Earth. So height above the surface, I have already explained. That is, we will find that in the figure, P is at a height, O is the center, R is the distance of a satellite from O, that is R is the radius of Earth. So P point is considered, that is at a distance RE plus H, where R is the radius of Earth and H is the height from the center of Earth. Now we know that acceleration due to gravity is inversely proportional to the square of distance, and the distance RE plus H is more as compared to RE. So gravity or acceleration due to gravity at point P will be less. So this is mathematically depicted. So mathematical relation is given, and finally we have to use binomial theorem in this expression. Therefore, G dash is less than G. G is the actual value and G dash is the value at position P. Now, we go above the surface of Earth, the value of G dash decreases and G is inversely proportional to R square for R is greater than RE. If H is very small than RE, according to binomial theorem, we use the binomial theorem and we will put the binomial theorem in a unit form. So we have written G dash is equal to G into 1 minus 2H over RE. And if R is infinity, G will be 0 at infinite distance from the Earth. The value of G dash becomes 0. Value of G at surface H will be 0. That is G is equal to GME over RE square. M is the mass of Earth and RE square is the radius of Earth. Now in the figure again, the same thing is depicted. So figure is same for all the cases. And now we come towards below the surface. As I have explained you earlier in my lecture, that is when we go deep into the Earth, the value of G goes on decreasing and the weight also decreases. That is what the statement given. The value of G decreases on going below the surface of Earth. The value of G at a distance h below the Earth's surface be GH, then GH is given as G into 1 minus h over RE square, or it is G RE minus h divided by RE is equal to GR over RE. So this we have used binomial theorem to make the calculations. Now GH will be less than G, that is GH is, that is the acceleration due to gravity inside the Earth at distance h from the circumference. Now from the center of Earth, R is less than RE or R is equal to RE minus h. If D is the density of the Earth, then force on point P will be how much? This is force point P. D is the density. Density is mass by volume or mass is density into volume. Volume can be taken as 4 over 3 pi r cube. And this is indicated in the next portion, that is GH is mRg over r square. mR, where mR is 4 by 3 pi RE minus h whole cube d. Basically, mass is volume into density. That values we have put here, and we estimated the value of r square. And GH will be equal to 4 by 3 G into RE minus h into d. Now, we find that at the center of the Earth, h will be equal to RE. That is, R will be 0. So, G will be 0. If G will be 0, weight will be 0. So, value of G is maximum at surface of Earth and it will be very less at the center of the Earth. Now, we will go through with the graphical representation of variation in the value of G. So, here in the figure, variation in the value of G on the surface of Earth. As I have explained you that G at the poles will be more and at equator it will be less because polar radius is less as compared to equatorial radius. This is what depicted in the figure.